writing out your equation using D's, E's, and F's, or whatever letters you have, is the key. Okay? For problem number 5, just write out. Don't try to sub in the numbers and do everything all at one time. Okay? Write out using what we have here and make sure I have a good equation. And once you get that good equation down with using your letters, then substitute your numbers in. Once you get the numbers subbed in, then it's a little bit easier to work with. Another question?
7.
Number 7. Triangle ABC. Triangle ABC. We have A is 2, B is 3, C is 4. And they want you to find the measure of angle A. Okay, measure of angle A. So, if I'm trying to find the measure of angle A, the cosine of angle A has to be at the end. Angle A, if we're trying to find angle A, it means the only time I have an angle in the law of cosine equation is at the end. So I have the cosine of angle A at the end. Once I get the cosine of angle A at the end, then I go to the beginning. Okay, and write out and fill out the rest of my equations. If I have cosine of angle A at the end, what has to be my letter at the beginning, Nick? If angle A is at the end, what has to be my letter out here? Last time I checked, the number 2 is not a letter. There we go. A squared. If I have little a at the end, big A at the end, I need to have little a at the beginning. Now I fill in the rest. Okay, it starts out with a Pythagorean idea. I have A I've used, B and C. I have B squared plus C squared. Pythagorean idea. Minus 2, and then we just recopy the B and the C. So we have 2BC, cosine of angle A. Once we get our equation down, now we start throwing in our numbers. So now we have the 2 squared is equal to 3 squared plus 4 squared, minus 2 times 3 times 4, cosine of angle A. Okay, when we're trying to use law of cosine to solve the angle, it's going to be the same process each and every time. Subtract your squares over. So I have 2 squared minus 3 squared minus 4 squared. And then you want to multiply these all together. Okay, the negative, get a coefficient for your cosine. So I have negative 2 times 3 times 4. Common mistake is to lose this negative sign here. 2 times negative 2 times 3 is negative 6 times 4 is negative 24. Cosine of angle A. Here I take my 4. Take my 4, subtract off 9, subtract off 16. So we have, let's see, we have 25, negative 21. Negative 21 there. We can then divide by our negative 24. So we have 21 divided by 24 is equal to cosine of angle A. And if you keep the negatives there, that is fine. But negative divided by a negative, they cancel each other out, so we have a positive. But if you keep them there, it's no big deal. Then we take our inverse cosine of negative 21 divided by negative 24. If you have 21 over 24, that is fine. You'll get the same solution. Problem number 11. When you went into problem number 11, you clickety-clacked it through the calculator, and you came up with a domain error. What's the issue you have with problem number 11? What property of triangles are we running into that we have issues with in problem number 11? We have G is 7, we have Y is 5, and P is 13. And if you try to work it through the problem, you'll get an error. Anybody know why? Yeah.
When the length of two sides are added together, it must be greater than that.
That's exactly right. We have G is equal to 7. We have Y is equal to 5. And we have P is equal to 13. I take two sides of a triangle, they must be greater than the third side. The reason why, well, if I go to draw something a little bit more anatomically correct. P is a value of 13. That's the length of P. G and Y are 7 and 5. So if I try to draw 7 and 5, here is my Y of 5, and here's my G of 7. And I cannot bring these up and connect them. Because this entire length is a value of 13, I can't connect these two sides together because this is only a length of 7, this is 5, this only adds up to 12. So I cannot connect these two to create a triangle. That's why that property is there. Length of any two sides has to be greater than the length of the third side, added together. Once again, please do keep up with the material. Opportunity is there for a grade, which for some of us will make up for your Trig identity grades that made your personal grade slide a little bit, maybe. Law of sines and cosines inverse trig is that opportunity to bring that grade up a little bit. Today we're going to talk about the law of sines. But before we deal with the law of sines, we have to take a look at the area of a triangle. The area of a triangle. How do we calculate the area of a triangle? 1/2 base times height. The area of a triangle is equal to 1/2 times our base times our height. 1/2 base times height. Now we calculate the area of a triangle. Now going to definitions, because talk about it all the time. Mathematics always goes back to definitions. What's our definition of a base? Our base is any side. It does not have to be the bottom. Okay, we all stick in our brain the base is the bottom. Yeah, in building a pyramid, the base is the bottom of the pyramid. But when we talk about a triangle, it can be any side here. The height is a segment perpendicular the segment perpendicular to the base to the opposite vertex. It's a segment that's perpendicular to the base. So one endpoint is on the base, the other endpoint is at the opposite vertex. We're going to look at triangle bend here. Triangle bend. So we have little b here, we have little e here, we have little n here. Sides opposite is the lowercase. I'm going to use my base as side E. Why? Because I just want you to get out of the idea that it has to be at the bottom of the triangle. So I'm going to draw my height in here. Because the height is a segment that is perpendicular to the base to the opposite vertex. So if I want to calculate my area, we have 1/2 times my base, which is E, times my height. Well, what we want to do is we want to be able to relate this back to lengths of sides of the right triangle, or lengths of sides of the triangle and angles of the triangle. Because I don't want to have to sit there and draw this height in every time. I want to be able to calculate my area by not having to draw this in and do a lot of manipulation. Well, if we take a look, we have two right triangles here. If we look at right triangle number 1, that we have angle B at the top. We have side, the entire side of the triangle N here. This is point E, but it's not the entire angle E. And this is part of E, but it's not the entire E. And that really doesn't matter because all we want to take a look at is here's my height. Here's our height in here. I know this entire side of the triangle. I know this angle B is the entire angle of this triangle. This entire side is N, this entire angle is B. And what I want to do is ask myself, which trig ratio will relate angle B to my height and the entire side I know, which is little n? No, which trig ratio would relate angle B to my height here and my entire side n? Because I have a right triangle, and if I have a right triangle, I have all my right triangle ideas. Sine. The sine of angle B is equal to opposite over hypotenuse, h over n. So my height would equal multiplying both sides by n times the sine of angle B. So I have 1/2 my base, which is E, times my height, which is n sine of angle B. So I can calculate my area that way. But I can also take a look at triangle number 2 down here, which gives me B here, I have the entire angle N. Here's my point E. Here's my little b. And I have a right angle here. And this is my height, h. Well, like we had up here in triangle 1, I know this entire angle N of the second triangle. I know my entire length B of the second triangle. Which trig ratio would relate this angle N to my H and B? Adam, which trig ratio will relate angle N to H and B?
Sine again.
Sine again. Sine of angle N is equal to what over what?
It'd be H over B.
H over B. So H is going to equal B sine of angle N. Multiplying both sides by B. So here, I can still have 1/2 E, but another way of saying my height is B sine of angle N. And this would be another way of calculating the area of this triangle. So I have 1/2 EN sine of angle B. I have 1/2 EB sine of angle N. Well, just like the law of cosines, there's 3 equations that can be written for the area of the triangle. Let's follow the pattern. I have 1/2 EN sine of angle B. I have 1/2 EB sine of angle N. I use angle B, and I use angle N. Haven't used angle E yet. What would be the third equation to calculate the area using angle E? Follow the pattern. I have 1/2 EN sine of angle B. Then I have EB sine of angle N. What would be the third one that would incorporate angle E?
N times sine of B.
N times sine of B. What would be my entire equation now? I have two sides being multiplied together times sine of an angle. Two sides multiplied together, sine of an angle. I want to have the sine of angle E at the end. What would be the two sides I'd have to multiply? EN, E and N, sine of angle B. E and B, sine of angle N. What would be the last one that deals with sine of angle E?
N and B.
N and B, very good. N times B, sine of angle E. Well, why'd you say N and B? You're correct, but why? What would tell, we had E and N, then we used angle B. Then we had E and B, then we used angle N. You said N and B, why did you choose N and B for the angle E? You're correct, but why?
They're kind of opposites.
They're kind of opposites. You have some opposite ideas there.
They're adjacent.
They're adjacent to it. Okay? They're adjacent to the two sides that's adjacent to the angle.
They make the point.
They make the point. They intersect at that angle. They form this angle. This E, B, and N, they form angle E. N and E form angle B. We have B and E, they form angle N. what we're talking about there is a geometric term that you use, which was called an angle included. So area of any triangle is equal to 1/2 product of two sides. 1/2 times the product of any two sides times the sine of the angle included. When we look at this angle included formed by these two sides. They're adjacent to it. Okay, they're right next to that point. What that's termed as is an angle that's included. So the area of any triangle is 1/2 times the product of any two sides. You're multiplying two sides together times the sine of the angle formed by those two sides. And now we'll calculate the area of any triangle. Which now leads to what we call the law of sines. No matter which one of these three that you utilize, you'll be able to calculate, and you should get the exact same area. The area does not change of that triangle. So 1/2 EN sine of angle B should equal 1/2 BN sine of angle E, which should equal 1/2 BE sine of angle N. No matter which one you use, you should come up with the same area. Now, using mathematics and multiplication property of equality, we're going to multiply everything by 2. If I multiply this side of the equal sign by 2, I multiply this side by 2. Then I can multiply that by 2. Well, what happens when I multiply everything by 2 is the 1/2s go bye-bye. So we're left with E times N sine of angle B equals B times N sine of angle E, which equals B times E sine of angle N. I'm just multiplying through by 2. If we have a triangle, we're guaranteed lengths of sides. B, E, and N, none of them are going to equal 0. If this is a triangle and one of those is equal to 0, then we don't have a triangle. So you have to have, all these have to have values that are not 0. Which means we can now divide by bend. We're dividing every term by bend. Well, if I have all multiplication here, I can do some canceling. And that's what I have, all multiplication. So the E's go bye-bye and the N's go bye-bye. And the second one, the B goes bye-bye and the N goes bye-bye. And the third one, the B goes bye-bye and the E goes bye-bye. Leaving us with the sine of angle B over little b is equal to sine of angle E over little e, which is equal to sine of angle N over little n. which is the law of sines. For any triangle, the ratio of the sine of the angle divided by the length of the side opposite is going to be in proportion. Length of the side opposite, these are going to be ratios. These ratios are going to be proportional, which means they're going to be equal. Let's look at triangle Timmy. Triangle Tim. So I have triangle Tim. Sides opposite. Lengths opposite, or lowercase. Before we do anything else, write 3 law of sines proportions here. What would the law of sines say about triangle Tim? Using only letters. Don't try to throw numbers in yet. Once again, use only letters. Keep it simple. So we should have sine of angle t over little t equals sine of angle I over little I, which equals sine of angle m over little m. Right? So start throwing some numbers in here. Angle t is 40. Angle I is 60. Little I is 10. You need to know three of the 4 to be able to solve. Well, I know angle t, I know angle I, and I know little I. So if I know those 3, I can solve for little t. So let's throw in our numbers. Sine of angle t over little t, sine of 40 over little t, equals sine of angle I, which is 60, over little I, which is 10. How do we solve a proportion? That's grade math. What do we do to solve this? Fifth grade math. Keep the cobwebs off.
Cross multiply.
Cross multiply and divide. Diagonally multiply and divide. So I can multiply. I have 10 sine of 40 is equal to t sine of 60. Then we can divide by the sine of 60. So we have 10 sine of 40 divided by sine of 60. Clickety clack, clickety clack. Bless you. 2 decimal places, what do you get? Anybody? Yeah.
7.42.
7.42. Go with that. Okay. Let's see here. We want to solve for little m. Problem is, I don't know angle m. Can I find angle m? Well, you use mathematics to find angle m. What's angle m have to be? 80. Because the angle sum of a triangle has to equal 180 degrees. So this has to be 80. So what I would do is I would go back to that one right there, because if I boost this one up with little t, and I try to use little t to solve for little m, m's going to be wrong. But I know this is true, I know this is 80, so I know that's 80, so now I can solve for little m. Go ahead and solve for little m. what's the 2 decimal places we get? 11 point what? 37. You good with that? Okay, side opposite, biggest angle, biggest side. Smallest angle, smallest side. And that always has to be true. Okay, what I want to do is I want to calculate the area. Okay, how do we calculate the area? We have the product of 2 sides times the sine of angle included. Okay, U5 right here. I want you to use angle M. Use angle M. U4 right here. I want you to use angle T. Back row, I want you to use angle I. Back row's angle I. We got T, we got I, and we got M.
So we're using M.
Yes.
Okay.
So you have the product of 2 sides times the sine of the angle included. Okay, I gave you the angle to use. So you have product 1/2 times the multiplication of the 2 sides times the sine of the angle included. Angle M, what did we come up with? 36.54. Good with that. Angle I, who had angle I? Back row, what'd you get? 36.43. Point what? 43. Angle T?
36.54.
36.54. We're off a little bit here just because of rounding. Okay, but these are all square units. Okay, once again, show me the work, show me the, and I'm not going to count off for a penny or two. Okay, your homework, you have 2 different pages, 229, page 229, 1, 3, and 5. That deals with areas of triangles. Then page 232, 233, 1 through 5, and 7. Those are all wall sines and cosines. All right, and that's also, once again, on Classroom. Questions you have? Adios, have a good day.